Hey there, this is Robert Kornacki, CSO at DC Spark. In this video, we're going to look at the upgradability smart contract for the Catalyst proposal, and this is the repo, which is now publicly available live. So, effectively, we implemented, after doing a lot of research into what is the best way to implement upgradability in a simple manner that can be replicated by developers who are also newer to Plutus and who might be more prone to making mistakes. And so how do we make this as simple as possible while still being secure? So we have a bit of a summary here at the start of the repo and the README. And so pretty much the protocol works as such that users of the protocol, the deployers of the protocol, which needs to be upgraded, must define a set of people who have admin rights, so to speak. And so these are a set of addresses which need to provide signatures. And so we implemented effectively a new multisig scheme in Plutus itself, such that with the multisigs, you have the ability to move the UTXO of your dApp from an old validator script to a new validator script. Furthermore, you can also upgrade the datum and the data being held within the datum potentially. And we've done some checks and tests to ensure that when upgrading to the new contract, you don't have any attack vectors. And so we make sure that you aren't like taking multiple input UTXOs and so forth that can try and destroy some of the guarantees where you typically assume you just have one input, one output for the upgradability of the dApp itself. But there's obviously ways to play that with having multiple inputs with the same validator script, for example. So all of that has been checked. Obviously, we have not audited this code because this grant did not include money for the audit. And so this is the core protocol implemented with tests, which I will show in a moment. And it all should be good. But this is obviously not production ready. And so any project that's learning off of this or using this or implementing off of this will obviously have to do their own audits because that's, on their end when they're trying to deploy in production. And so effectively, by implementing this protocol, which relies on a treasury token or a treasury NFT, which is what distinguishes the UTXO, and then with the signature gathering, we have the ability to move a dApp UTXO from a validator script A to a validator script B. We have instructions for how to build and how to run the tests. Jumping into the actual code itself, we have a source folder which separates the utility functions on-chain and off-chain code. The off-chain code is the actual off-chain logic that allows you to lock funds and perform various capabilities. We also have some endpoints for interacting, with the protocols that are being upgraded from and upgraded to. Lastly, we have the on-chain contract, which is a set of functions, for example, to check the signatures of the multisig that we implemented, defining the datums, the various different parts. We also have the different validator scripts and that you're upgrading from, upgrading to, and then the actual logic for the migration. Lastly, in the repo, we have tests, and effectively we split this up with the endpoints of what the tests will run against. We have the basic scenarios, which is the positive tests to verify that the functionality of upgrading works as expected. And so these are what they do. And then we have malicious endpoints, which are the tests of what if someone who's a bad actor is trying to exploit the protocol and do stuff that they shouldn't do, such as migrating from validator script A or smart contract A to smart contract B with no signatures. That's checked against. migrating with no token. And so if someone creates a fake UTXO and tries to do something there, they can't do that. And migrating with different value, so someone can't withdraw money while upgrading from smart contract A to smart contract B. And so with all of that, we effectively have the on-chain, off-chain code, the endpoints, the tests, and a basic summary so people can understand the protocol. With all of that together, we effectively, delivered a pretty good, concise repo here, which allows developers to understand how upgrading works, look at the code themselves, copy and integrate this into their stack for their dApps, and as such, we have a public open source repo and smart contract, which now the ecosystem can use as a solid foundation for the future of Boost apps. Thanks for watching.